AP scoring guidelines can change from year to year, so here's my suggested steps for confidence intervals to ensure you display solid understanding and earn full points regardless of what may or may not get scored in a particular year. Last summer, 36 underprivileged third graders whose reading scores had fallen over the previous summer were randomly selected to interact with the learning gadget at least 12 hours per week. Their mean reading score at the end of the summer was 4.05. Assume the population standard deviation is 0.8. Construct and interpret a 95% interval for the mean reading score of all underprivileged third graders who would use the gadget over the summer. Step 1. The unknown parameter we'll estimate is the mean reading score of all underprivileged third graders who would use the gadget over the summer. The sampling distribution utilized is approximately normal due to a sample of at least 30, ours was 36. We're told that 36 of these underprivileged third graders were randomly selected. There is a large population of underprivileged third graders who might ultimately use the learning gadget, and we can use a z-interval due to being told to assume a population standard deviation of 0.8. We use the AP formula sheet to write our sample mean reading level of 4.05 and add and subtract the margin of error, which is the critical value, the critical z-score that traps the percent of sample means equivalent to the confidence level, times the standard deviation of the sample means. We should have memorized the z-score of 1.96 in this case. Doing the math, we get an interval from 3.79 to a reading level of 4.31. We're 95% confident that the mean reading score of all underprivileged third graders who would use the gadget over the summer following a summer of declining reading level would be between a 3.79 grade level and a 4.31 grade level. You might be asked if this suggests a mean reading level greater than 3.5. That might be a typical type question. We'll practice this as time goes on. Our response, since our 95% interval is entirely above a mean of 3.5, the answer would be yes. Very quickly, what if we were asked to construct a 93.6% confidence interval, allowing us to demonstrate our understanding of the critical z-score required? We would picture the middle 93.6% of a normal distribution, recognize that 1 minus this leaves 6.4% to be distributed evenly on the two tails, so we would use inverse norm of 0.032 in the standard normal distribution of z-scores and obtain a critical z-score of negative 1.85, so we'll replace the 1.96 with plus or minus 1.85, recalculate the interval as being from 3.80 to 4.30, and then adjust the interpretation accordingly.